Hello, welcome to In 5 Minutes. Next is the design problem from December 14 paper, again for 10 marks. The question tells us to design the JFET circuit having voltage divider biasing with JFET. Now again we can identify which type of JFET it is. Again it is N channel JFET. This is your gate, this is your drain, this is your source. Now they have given R1 plus R2 as 100K, IDQ and VDSQ they have given, IDSS VP. Since lambda is 0, that means we need not consider small RO, so it is considered as infinite. Lambda indicates the output resistance to be infinite. They have told us to find the value of RD, R1 and R2. Now since the current flowing through the drain is given, so the same current flows through the source, so we can find voltage at the source. So when you apply KVL in this loop, your equation will be, it is KVL to source loop. So when you apply KVL, the equation will be Vs minus ID into Rs plus 5 equals to 0. So you can find voltage at the source as ID Rs minus 5. IDQ in the equation is given as 5 milliampere, RS is 0.5 minus 5, so we'll get VS as minus 2.5 volts. Now why we are doing this? Because if we find the voltage at this point and if we apply KVL over here, since the current flowing through this ID is given, we can find the value of RD. So for that we require to find the value of VD, and how to find the value of VD is, we know VDS is VD minus Vs. VD is given, Vs we have found out, so we can find voltage at the drain. So it is 5 and this is minus 2.5, so we get VD as 7.5 volts. So voltage at the drain you have got. So when you apply KVL in this loop, which is indicated in the diagram, the equation for the KVL will be 5 minus ID RD minus VD equals to 0. So the equation KVL to drain loop will be 5 minus ID into RD minus voltage at the drain equals to 0. So you can say 5 minus ID into RD minus 7.5, so 0. So this will give you the value of output resistance RD as 0.5 kilo ohms. So we have got the value of RD. Now we need to find the value of R1 and R2. When you look at the diagram, voltage at this point, we can say voltage at the gate, we can write Vg as R2 upon R1 plus R2. 5 minus of minus 5 will be plus 5, the whole say minus 5. This will be the voltage at the gate, because you have two voltage sources over here, one is plus 5 and another is minus 5. So that is the gate voltage Vg. So this is the equation for Vg. Now since in the question, if you write the Shockley's equation, which is ID is IDSS 1 minus VGS by Vp the whole square. Now from this equation, if we get the value of VGS, VGS will be Vg minus Vs. From this equation you will get VGS, then Vs you know, then you can solve for Vg, right? So for this, IDSS is given in the question, the value is 12 milliamperes. VGS we don't know. Vp is given as minus 3.5 the whole square, and ID is given as IDQ as 5 into 10 raised to minus 3. So when you solve this, you will get VGS as minus 1.24 volts. So when you got VGS as minus 1.24 volts, you substitute over here, it will be minus 1.24. Vg equation, you know, R2 upon R1 plus R2 into 5 plus 5, 10, the whole minus 5. Minus voltage at the source, we have already found it as minus 2.5, so it will be plus 2.5. So when you substitute, R1 plus R2 is given in the question as how much? 100K. So from this only one unknown, that is R2. So that will give you R2 as 12.6 kilo ohms. Once you have got the value of R2, you can find the value of R1, because R1 plus R2 should be 100k. So 100 minus 12.6 will be 87.4 kilo ohms. So this is how to solve the problem for 10 marks. Thank you for watching in 5 minutes. For further concepts, kindly keep watching.